Hello everybody, welcome into another lesson. So today we are going to talk about something called partial fraction decomposition. And this is very important because this is heavily used in calculus, especially with integration. So what is the idea of partial fraction decomposition? Let's say you have something like 1 over x squared minus 1. Well, that x squared minus 1, as we know, is a difference of two squares, which factors into the product of two linear factors. Well, the idea is you have two factors in your denominator. You can separate these into some constant a over the first factor plus some constant b over the second factor. And at the end, whatever values you get for a and b, if you go to multiply both of these and get the same common denominator, you should end up with your original expression that you had. And this actually uses systems of equations to solve for these variables. So let's go ahead and get started here. The first segment of this is going to be non-repeated linear factors in the denominator, such as what we have here. Each of these is only a factor to the first power, so these are non-repeated linear factors. So how are we to solve for something like this? Well, you're going to take that 1 over x plus 1 times x minus 1 equals a over x plus 1 plus b over x minus 1. So your common denominator is the product of x plus 1 times x minus 1. You're going to multiply both sides by that denominator. What you should end up with at that time is 1 equals a times, now if you multiply a over x plus 1 times the denominator, the x plus 1's will cancel out. You'll end up getting a times x minus 1 plus b, and then if you multiply this b over x minus 1 times the denominator, the x minus 1's will cancel out. You would end up getting b times x plus 1. And then what you're going to do to go from here is you're going to use the distributive property and you're going to expand the right-hand side. So you'll get 1 equals ax minus a plus bx plus b. Now, where do we go from here? What you need to do is get all your x to the first terms by get them together, group them together. So this should be 1 equals ax plus bx. And then you have minus a plus b. Well, you notice with your x terms, you can factor out a common x, right? So that would be 1 equals the quantity of a plus b times x. And then really, that just negative a and b, you could just say plus negative a plus b. Alright, so what are we going to do with that? So that a plus b is going to be matching the coefficient of your x to the first term on the left-hand side, and then that negative a plus b with no variable should match the constant term on your left-hand side. If we look here on the left-hand side, you have no x to the first term. All you have is a constant term. Well, your x to the first term would be 0. That would be like a 0x plus 1, right? So what you got to do is take that a plus b, you're going to set that equal to 0, and then that negative a plus b equals your constant term. That means negative a plus b equals 1. Now you just have a simple system of equations with only two variables. And we can definitely add these together and we can eliminate a. We can use elimination. A minus a is 0. B plus b, that's 2b, would equal 1, which means b is going to equal 1/2. We found b to equal 1/2. Now what about a? Just substitute that into one of these two equations and you'll be able to solve for a. Let's pick the top one. So a plus 1/2 equals 0, which should mean that a equals negative 1/2. We found a and b, so now we have the partial fraction decomposition of 1 over x squared minus 1. That's going to be the exact same thing as negative 1/2 all over x plus 1 plus 1/2 all over x minus 1. And that would be your answer for the partial fraction decomposition of this particular fraction. And it's perfectly acceptable to leave your answer like that. In fact, in calculus, it would be beneficial for you to leave it that way. But more on that when we get to calculus, of course. We'll do some more non-repeated linear factors first. Then next we'll move into repeated linear factors. But let's do a few with non-repeated linear factors. Okay, so let's say I have 1 over 4x squared minus 9. So I got 1 over 4x squared minus 9. Clearly, again, in the denominator, we have a difference of 2 squares. So we can factor that difference of 2 squares. That would factor into 1 divided by 2x plus 3 times 2x minus 3. Right? And as you see, this factored into the product of two non-repeating linear factors in the denominator. Well, that's your common denominator. You can break this up into some constant a over that 2x plus 3 factor plus a b over that 2x minus 3 factor. Okay? Now, what you need to do again, your common denominator is 2x plus 3 times 2x minus 3. So multiply both sides by that denominator. So, of course, on the left side, you would just get 1 because the denominator would cancel out. You multiply the first term, the 2x plus 3's would cancel out. You'll end up getting a times 2x minus 3 plus b times, if you multiply this by the common denominator, the 2x minus 3's would cancel out. You would get b times 2x plus 3. All right. So now we have the first form. Next thing you're going to do is distribute your a's and b's. So 1 would equal 2a times x minus 3a plus 2b times x plus 3b. Okay. Now the next thing you want to do, again, group your x terms together, and then the terms without the x, group those together. So 1 would end up equaling 2ax plus 2bx, and then you'll just have minus 3a plus 3b. All right, now we need to, of course, for the first two terms, since we got our x terms together, we need to factor out that x. That's why I say get your terms together, to make your life a lot easier. So 1 would equal the quantity of 2a plus 2b times x. And then you could say plus negative 3a plus 3b is equal to 0. All right. Now again, the left side should equal the right. So the 2a plus 2b times x, that was going to represent the coefficient on your x to the first term on the left-hand side, which in this case is 0. So we're going to set 2a plus 2b equal to 0. And then we have negative 3a plus 3b. I don't know why I put equals 0 here. Forgive me. That negative 3a plus 3b should end up equaling your constant term on the left-hand side. So negative 3a plus 3b is equal to 1. Well, I'm going to use elimination. I mean, we could do substitution. It doesn't matter. But I think if we multiply the top one by 3 and the bottom one by 2, we can eliminate a. So multiplying the top equation by 3, you get 6a plus 6b is going to be equal to 0. And then if you take the bottom equation, multiply it by 2, you'll end up getting negative 6a plus 6b equals 2. Now all you have to do is add these two equations together, and then you can eliminate the a variable. So 6a minus 6a is 0, 6b plus 6b, that's 12b. That's going to equal 2, which means b would equal 1/6. All right, so we found the value of b. Now what about a? Well, I need to put in that b into one of these two equations, and then I could end up solving for a. So I'll pick the top one. We'll say 2a plus 2 times 1/6 equals 0, which would give you 2a plus 1/3 equals 0. So 2a equals negative 1/3, which would mean a would have to equal negative 1/6. So now we have found both a and b. We have the values of a and b. We have our partial fraction decomposition, which would end up equaling negative 1/6 all over that 2x plus 3 plus positive 1/6 all over 2x minus 3. And again, if you're unsure if you got the right answer, all you have to do is get your common denominator, do the multiplication, and add the fractions, and you should end up with your original expression. That's how you would check it. All right. Let's still do some more non-repeated linear factors. Okay. What if I had something like 1 over x squared plus x? I have 1 over x squared plus x. Very clearly, we can factor out an x. So that's going to end up equaling 1 over x times x plus 1. So we have two non-repeated linear factors. So again, your partial fraction decomposition would end up being a over that factor of x plus b over that factor of x plus 1. Now, of course, you're going to multiply both sides by that common denominator of x times x plus 1. So you should end up with 1 equals a. Then if you multiply this term by the common denominator, the x should cancel out. You should end up getting a times x plus 1 plus bx. So let's distribute the a. 1 would end up equaling ax plus a plus bx. Next, let's group our x terms together. So 1 would end up equaling ax plus bx plus a. Well, you have your x terms together. Let's factor out that x. So 1 would end up equaling a plus b times x plus that a. All right, so again, the left side should equal the right. A plus b would be the coefficient on your x to the first term on the left, which would be 0. So a plus b is going to equal 0. And then that a would just equal your constant term of 1. Well, we just found a right away. If we want to solve for b, just put it into the other equation. So you would get b plus 1 equals 0, which would mean b equals negative 1. So we found a and b. Now we have our partial fraction decomposition. So that's going to be equal to 1 over x minus 1 over x plus 1. And therein is your partial fraction decomposition of the original expression. Let's do two more non-repeated linear factors. All right, so let's do 5 minus x all over 2x squared plus x minus 1. So we have 5 minus x over 2x squared plus x minus 1. Well, again, really and truly what we should be doing, and you're going to see why in a little bit, is we need to see what the degree of the numerator and the denominator is. In this case, the degree of the denominator is less than that of the numerator, so we can continue doing what we've been doing. If it's greater than or equal to the degree of the denominator, well, we'll cover that when the time comes. But let's go ahead here and factor the denominator. So this would end up equaling 5 minus x all over the factors here, which would be x, and then you'll have a 1, and then a 2x and a 1. So 2x squared minus x plus 2x would give you that plus x, the minus 1. Okay. So we found the factored form of the denominator. It's going to be 5 minus x over x plus 1 times 2x minus 1. So that's your common denominator. Well, we can separate this into a over your first factor of x plus 1 plus b over your factor of 2x minus 1. Now, of course, again, the goal is the same. Multiply both sides here by your common denominator. You'll end up with 5 minus x is equal to, if you multiply the first term by the common denominator, that's going to be a times 2x minus 1. Plus, if you take your second term, multiply it by the common denominator, that would just turn into b times x plus 1. All right, let's go ahead and distribute now. So you'll end up having 5 minus x is equal to 2ax minus a plus bx plus b. Now, of course, group your terms together on the right-hand side. So you'll have 5 minus x equals 2ax plus bx minus a plus b. And then, of course, your first two terms, go ahead and factor out that x. So you'll have 5 minus x equals the quantity of 2a plus b times that x, and then you could just say plus that negative a plus b. All right, so there's your factored form on the right hand side. Again, your left side should equal your right. So 2a plus b would correspond to the coefficient of your x to the first term on the left hand side. Well, we do have a coefficient on the left-hand side. It's negative 1. So in this case, you'll set that 2a plus b equal to negative 1. And then that negative a plus b should correspond to your constant term on the left-hand side, which would be positive 5. So you'll end up with negative a plus b is going to be equal to 5. Okay. Well, both of these equations in the system, you have a positive b, so if we subtract the first equation from, subtract the second from the first, that we should be able to cancel out the b's. So 2a minus negative a turns into positive 3a Negative 1 minus 5 is negative 6, which should just give me that a equals negative 2. Alright, so we just found a. We can easily find b if we put that into one of these two equations. Let's pick the top one. So 2 times negative 2 plus b equals negative 1, which means b minus 4 equals negative 1, so b equals 3. So we found a and b. Now we have the partial fraction decomposition, which would end up being negative 2 over x plus 1 plus 3 over 2x minus 1. So there is your partial fraction decomposition. Negative 2 over x plus 1 plus 3 over 2x minus 1. One more non-repeated linear factor, and then we're going to go on to some repeated linear factors. All right, so let's do x minus 2 divided by x squared plus 4x plus 3. So we've been given x minus 2 over x squared plus 4x plus 3. Alright, so we're going to find the partial fraction decomposition of this fraction, but first, in order to do that, we need to factor the denominator. So that's going to factor into, the numerator stays the same, x minus 2 over the quantity of x plus 1 times the quantity of x plus 3. So that was an easy factorization, and again, you have two non-repeated linear factors where the degree of the numerator is less than the denominator. So this will break down into a over x plus 1 plus b over x plus 3. Now, of course, you'll multiply both sides by your common denominator. If you do that, you'll be left with x minus 2 is equal to a times x plus 3 plus b times x plus 1. Alright, so now we'll go ahead and distribute. You'll have x minus 2 equals ax plus 3a plus bx plus b. Okay, so now let's get our x terms together. So you'll have x minus 2 equals ax plus bx plus 3a plus b. And of course, with your x terms, go ahead, factor out that common x. You'll end up getting x minus 2 is equal to the quantity of a plus b times that x. And then you could write plus that quantity of 3a plus b. And then again, the left side should equal the right. So that a plus b should be the coefficient on your x to the first term, which on the left side, that coefficient is 1. So we'll set a plus b equal to 1. And then you have that 3a plus b should equal your constant term on the left-hand side, which would be negative 2. So you'll end up having 3a plus b equals negative 2. Well, it looks like we can definitely eliminate b, so let's subtract the second equation from the first. A minus 3a is going to be negative 2a equals 1 minus negative 2, which will turn into 1 plus 2, which is 3. So that means a should be equal to negative 3 halves. So we found a. Now what about b? That's going to be easy enough. If we just substitute that into one of these two equations, we can find b. So that means negative 3 halves plus b equals 1, which means b would have to equal 5 halves. Now we found a and b, we have just found our partial fraction decomposition. So that's going to be -3/2 all over x plus 1 plus 5/2 all over x plus 3. And there you have your partial fraction decomposition for this particular fraction. Let me get a different marker before I shift gears. Alright, so now we're going to go on to repeated linear factors. And believe it or not, it's really not that bad for repeated linear factors. We're going to start with the power of the numerator is still less than that of the denominator, the way we've been doing it so far. So I'll present some to you here. Well, what do we got here? Actually, let's do one more where we have non-repeated linear factors. There's a reason for that. So I'm going to have x squared plus 12x plus 12 all over x cubed minus 4x. So I have x squared plus 12x plus 12 over x cubed minus 4x. This will be the last one of non-repeated linear factors. Well, the degree of the numerator is still less than that of the denominator, but we can definitely factor out the denominator first. This is going to factor into x squared plus 12x plus 12 all over x times x squared minus 4. Well, that'll factor a step further, won't it? Because x squared minus 4 is a difference of two squares. So what you'll really have then is x squared plus 12x plus 12 all over x times x plus 2 times x minus 2. So in the denominator, you have 3 non-repeated linear factors. So that can be broken down into a over my x plus b over my x plus 2 plus c over my x minus 2. So yes, I have 3 separate factors for each of these linear factors, 3 separate fractions. Now, of course, you're going to multiply both sides by your common denominator. If you do that on the first, well, you do it on the left side, you'll just get x squared plus 12x plus 12 would equal, now the first term on the right-hand side, the x's would cancel out. You would end up with a times x plus 2 times x minus 2. Now plus b, well, if you multiply your second term by the common denominator, the x plus 2's would cancel out. You would just have b times x minus 2, plus then your third term, if you multiply both sides by the common denominator, the x minus 2's would cancel out, so you'd have plus c times x plus 2. So let's go ahead, distribute everything, do what we need to do over there. So you would get x squared plus 12x plus 12 equals a times x squared minus 4 plus bx squared minus 2bx plus cx squared plus 2cx. All right, let's simplify the right-hand side a little more. So you'll end up getting x squared plus 12x plus 12 is going to end up equaling ax squared minus 4a plus bx squared minus 2bx plus cx squared plus 2cx. Now, of course, we need to group everything together on the right. You have a constant term, just one. You have several x to the first terms. We actually have two of those, and then you have 3x to the second terms. You need to group each of those together by themselves. So you would get x squared plus 12x plus 12 is equal to, let's group the x squared terms together. That would end up being ax squared plus bx squared plus cx squared. And then now let's deal with the x to the first terms. Then you would end up having minus 2bx plus 2cx. And then you just have a single constant term, which would be minus 4a. And then, of course, like before, you need to factor out the common factors. So you would have x squared plus 12x plus 12 is equal to a plus b plus c times that x squared. And then you have 2x to the first term, so that would be plus negative 2b plus 2c times your x to the first term, and then you just have a minus 4a. Again, the left side needs to equal the right, so that a plus b plus c will correspond to the coefficient of your x to the second term on the left, which is 1. So you'll set a plus b plus c equal to 1. Then that negative 2b plus 2c, that's going to actually end up being the coefficient of your x to the first term, which is 12. So you should end up getting negative 2b plus 2c equals 12. And then that negative 4a by itself would equal the constant term on the left, which would be 12. So negative 4a equals 12. Well, here's some good news. We can solve for a right out of the gate. A is just going to equal negative 3. So we found the solution to a, but we still need to figure out b and c. Well, the best piece of advice I can give you is look at your top equation, a plus b plus c, substitute the a in. So let's do that here. So you'll end up getting b plus c minus 3 equals 1, and then you'll have negative 2b plus 2c equals 12. Well, these two would simplify further into b plus c equals 4, and then negative 2b plus 2c equals 12. Well, if we multiply the top equation by 2, we can actually add these two equations together and cancel out the b term. So let's go ahead and do that. Sorry, I'm running out of room. So that would turn into 2b plus 2c equals 8, and then negative 2b plus 2c equals 12. Now all I got to do is add these two equations together. The b's are gone. I get 4c is equal to 20, which 4c equal to 20 means c equals 5. So I got a, I got c. Now all I have to do to solve for b is put that into one of these equations here. So I'm personally going to pick b plus c. I'll personally pick that. So that would end up being b plus 5 equals 4, which would have to mean that b equals negative 1. So now we have a, b, and c. We found the partial fraction decomposition. Here's my a of negative 3. Here's my b of negative 1. Here's my c of positive 5. So this would turn into negative 3 over x minus 1 over x plus 2 plus 5 over x minus 2. That would end up being my partial fraction decomposition for this particular fraction. So that's how you can do it with multiple non-repeated linear terms. Let's truly go on to repeated linear terms this time. Believe it or not, it's not too different. All right, so let's say I have something like 2x minus 3 all over x minus 1 quantity squared. So still the degree of the numerator is less than that of the denominator, but the denominator is a single repeated linear factor because it's got a power of 2. How do we handle that? Okay, so whenever you have a repeated linear factor, if it's just to the second power, that's going to be the same as a over x minus 1 just simply to the first power, plus b all over x minus 1 raised to the second power. That's how you deal with repeated linear factors. Because your common denominator would be x minus 1 squared, so you have one denominator that's just x minus 1 to the first and one that's to the second. If it were to the third, we would have 1 to the first, 1 to the second, and 1 to the third. But let's go ahead and do this partial fraction decomp. So you have to first multiply both sides by the common denominator of x minus 1 squared. If we do that, the left side would just turn into 2x minus 3. That's going to end up equaling your right-hand side. If you multiply the first term by x minus 1 squared, this would just turn into a times x minus 1. Plus your second term times the common denominator would simply be just b. So let's go ahead and expand the right-hand side out. So you'll have 2x minus 3 equals ax minus a plus b, which would mean 2x minus 3 equals that ax. You only have one x term plus that negative of a plus b. And again, the left side should equal the right, so a would be the coefficient on your x to the first term, which is 2. So right out of the gate, you have that a equals 2. And then that negative a plus b is going to be your constant term on the left-hand side, so negative a plus b would equal negative 3. Well, I think it's pretty easy to solve for b in this case. We just put that a value into the second equation, so you'll get negative 2 plus b equals negative 3, which would have to mean that b equals negative 1. So we just found our partial fraction decomp. That's going to turn into 2 over x minus 1 minus 1 over x minus 1 squared. And there's your partial fraction decomposition of this original fraction. And I got a couple more repeated linear factors. And then we're actually going to do some unfactorable quadratic factors and show you how that works. So what if I give you something like this? 27 minus 7x all over x times x minus 3 squared. So you have 27 minus 7x over x times x minus 3, the quantity squared. So you have one non-repeating linear factor, and then you have one repeating linear factor. So how's that going to work? Well, you could still take an a over that non-repeating factor of x, but then that you're going to focus on the x minus 3 squared part. That'll be a plus b over x minus 3 raised to the first power plus c over that x minus 3 raised to the second power. So now you have the setup for your partial fraction decomp. And of course you need to multiply both sides by the least common denominator here. So if you do that, the left-hand side just turns into 27 minus 7x. Now, let's go to the right-hand side. If you multiply the first term by the common denominator, you would just end up getting a times x minus 3 squared. Plus, now you have the second term. If you multiply by the common denominator, you would end up getting bx times a single x minus 3. Then you multiply the third term by the least common denominator, you would just get plus cx. That's how that's going to work. All right, let's go ahead and expand these, distribute, what have you. So 27 minus 7x would equal a times that quantity squared, which would be x squared minus 6x plus 9, plus bx squared minus 3bx plus cx. Okay, so let's distribute the a. So 27 minus 7x is going to equal ax squared minus 6ax plus 9a plus bx squared minus 3bx plus cx. Okay. So let's go on ahead now, group your terms together, group your like terms together. So 27 minus 7x, group your x squared terms together. That's going to equal ax squared plus bx squared. That's it for your x squared terms. Now let's focus on your x to the first terms. You'll have minus 6ax minus 3bx plus cx, and that's it for your x to the first terms. Then you only have one single constant term, which would just be plus 9a. And of course, you're going to go through, factor out your common terms. So you'll have 27 minus 7x is just going to end up equaling a plus b times x squared. You got your x to the first term, so that'll be plus negative 6a minus 3b times x. Actually, I missed the c. Whoops. Minus 3b plus c times x. That can make a big difference. And then you have plus 9a. All right. So the left side should equal the right. So a plus b would be your coefficient on the x squared term, which there isn't one. So that simply is going to mean that a plus b is going to equal 0. And then you are going to have that negative 6a minus 3b plus c equals the coefficient of your x to the first term, which is negative 7. And then that 9a should equal your constant term, which is 27. So 9a equals 27. This is actually a pretty simple system to solve, because a is just going to equal 3. If we put that a into the top equation, we can readily solve for b. So b plus 3 equals 0. Here's my a. Let me circle that, which means b equals negative 3. We have both a and b now. So I can put both the a and b value into my second equation, and I can readily solve for c. So I'll end up with negative 6 times 3 minus 3 times negative 3 plus c is equal to negative 7. So that's going to give me negative 18 plus 9 plus c equals negative 7, which would have to mean that c equals 2. So now I found all three constants. We have the partial fraction decomp. So that's going to be 3 over x minus 3 over x minus 3 plus 2 over the x minus 3 squared. I'm going to do one more of repeating linear factors, then we're going to do a few unfactorable quadratic factors in the denominator. All right. Let's say I just have 5 over the quantity of x minus 2 to the third power. So I'm going to give you 5 over x minus 2 to the third power. So we just have a single repeating linear factor, so that of course would split into a over my x minus 2 raised to the first power plus b times my x minus 2 raised to the second power plus a c over my x minus 2 raised to the third power. So there's the format we're going to need to do the partial fraction decomposition. Now go ahead, multiply both sides by the common denominator, which would make the left side just become 5. Multiply the first term of the right side, you'll end up with a times the quantity of x minus 2 to the second power. Multiply your second term by the common denominator, that'd be plus b times x minus 2 to the first. Multiply your third term, you would just get plus c. So that's not so bad. Okay. So now we need to go ahead and simplify the right-hand side. So 5 is going to equal a times x squared minus 4x plus 4 plus bx minus 2b plus c. Okay, so now this will turn into 5 equals ax squared minus 4ax plus 4a plus bx minus 2b plus c. And of course you want to group like terms to make your life easier. So you'll end up with 5 equals, you just have a single x squared term by itself, so ax squared. Now group your x to the first terms by themselves, so that'd be plus that negative 4a plus b times your x, and then you're going to end up wanting to group your constant terms together, so that would be plus the 4a minus 2b plus c. Okay, now we got it perfect. We got it just perfect here. We got everything factored. So here's what we got to do now. So we're going to see what a would equal, because that should be the coefficient of our You know what? It just dawned on me we're going to end up with 5. So why don't we do a 5 plus x? That might make our life easier. I hate to do all that work just to get to, 5 again and be left with our original expression, which sometimes you'll have that. As a hint, in order for the partial fraction decomposition to not go back to the original form, your power should really be no less than 1 in the numerator than the denominator, but that's okay. You'll have that sometimes. So, anyway, a is the coefficient of my x squared term, which is 0. So, a is going to equal 0. We can go ahead and circle that. Now, we have negative 4a plus b should be the coefficient of my x to the first term. So negative 4a plus b would equal 1. And then my 4a minus 2b plus c should equal my constant term of 5. Well, I think we can use a lot of substitution, because if a equals 0, that literally means b equals 1. So we got b right away. And we can solve the third equation by putting in both a and b. So you'll have 4a is 0. Don't even bother with that. You'll just have negative 2 plus c equals 5, which would just end up giving you c equals 7. So here's your partial fraction decomp. A is going to be 0, so the first term's irrelevant. This will just turn into 1 over x minus 2 squared plus 7 over x minus 2 to the third. That would be the partial fraction decomp for this original expression. Alright, so now let's go on to some unfactorable denominators, where we're still going to, right now, we're going to do the degree of the numerator is less than the denominator. I'd like to show you how that works. So what if I gave you 1 over something like x times the quantity of x squared plus 1? What the heck are we going to do with that? X is a perfect non-repeating linear factor, right? But what about x squared plus 1? That doesn't factor over the real numbers. So let's show this to you here. Of course, take your linear factor first, that x, that'll be a over x, plus, if you have an unfactorable quadratic factor in the denominator, how it's going to work is the degree of the numerator for your second component of this partial fraction decomp should be exactly 1 degree less. So that means it's going to be in the form of plus a bx plus c all over the x squared plus 1. So it should actually be, for your x squared plus 1 factor, the degree of your numerator should be just 1 degree less than the degree of the denominator. So, and we'll do some more examples of these, but what you need to do now is go ahead, multiply both sides by your common denominator. This would just turn into 1 equals the first term times the common denominator would be a times x squared plus 1, plus, now if you take your second term, multiply it by the common denominator, you would end up having bx plus c times x. So let's go ahead and expand everything on the right hand side. You'll have ax squared plus a plus bx squared plus cx. Well, okay. So let's go ahead now and let's go ahead and group everything together that we need to. So 1 would equal ax squared plus bx squared. Now you have plus a single cx, then you have plus an a. This should make factoring pretty easy. You'll have 1 equals the quantity of a plus b times that x squared plus cx plus a. Again, the left side should equal the right, so you're going to end up having then that a plus b is the coefficient of your x squared term, which would be 0. A plus b is equal to 0. C is the coefficient of your x to the first term, which would be 0. And then a is the constant term, which would be 1. So we have a right away. We know c is 0. There's nothing we can do with that. But then you'll end up having a plus b. You could put in a for and solve for b. So you get b plus 1 equals 0. So b would equal -1. So c is 0, but we do have a and b. So the partial fraction decomp in this case is just going to turn into your a over x. So 1 over x minus x over x squared plus 1. And that would be the best you could do for your partial fraction decomp. Since your c was 0, that's all you would get. I got more factors like that. I got more problems like this here. So let's do something similar. But let's throw in some other variable. Throw in another variable on the top. So let's say I have x plus 3 all over x squared plus 2. Well, no, that's not good. Over x plus 1 times the quantity of x squared plus 2. That looks a little hideous, doesn't it? You have x plus 3 all over x plus 1 times x squared plus 2. We have a nonlinear factor, and then we have a non-repeating linear factor, and then we have an unfactorable quadratic factor. Well, let's go ahead now and break this down. So first you're going to deal with a non-repeating linear factor. That would just be a over x plus 1 plus, now what I have to do for my unfactorable quadratic factor is my numerator should be exactly 1 degree less than the denominator. So this would turn into plus bx plus c all over x squared plus 2. Okay, now you just multiply both sides by the common denominator, so you'll end up getting x plus 3 would equal a times x squared plus 2 plus the quantity of bx plus c times x plus 1. So let's go ahead and expand out our right-hand side. So x plus 3 would equal ax squared plus 2a plus bx squared plus bx plus cx plus c. Now we just want to group everything together, right? So you'll have x plus 3 would equal ax squared plus bx squared. So all my x squareds are grouped together. Now let's focus on the x to the first. Plus the bx plus cx. Now all we need to do is group my constant terms together. Plus 2a plus c. Alright, so now we can factor out everything in common here. So x plus 3 would end up equaling the quantity of a plus b times x squared plus the quantity of b plus c times x to the first plus the quantity of 2a plus c. All right, so my a plus b should be my coefficient of x squared, which is 0. So a plus b equals 0. B plus c is my coefficient on x to the first, so b plus c is going to equal 1. And then 2a plus c should be my constant term, so 2a plus c equals 3. Well, I think we can readily do a substitution from the first equation, and we can get that a equals the negative of b. A equals the negative of b is going to be a useful substitution because now all I have to do is put these into the bottom two equations and I can solve for b and c. So that's going to mean that b plus c equals 1, and then if I'm substituting negative b for a, that would be negative 2b plus c equals 3. Now I can just subtract the second equation from the first and eliminate c temporarily. So b minus negative 2b turns into 3b, c minus c is 0, and 1 minus 3 is negative 2. So that means then that b would equal negative 2/3. So we found b. Now if a is the negative of b, negative 2/3 means a equals positive 2/3. So we found a. Now all we got to do is substitute a or b into one of our original equations and we can solve for c. I'll pick b plus c, so negative 2/3 plus c equals 1, so c would equal 5/3. So now we have found a, b, and c, so now we have found the partial fraction decomposition, which is going to end up being 2/3 over x plus 1 plus, I can say, negative 2/3 x plus 5/3 all over x squared plus 2. That is going to be my partial fraction decomposition for the original fraction here. Now let's pick one that has repeating quadratic factors that can't be factored. Let's show you that. Alright, so let's say I have x squared plus 2x plus 3 all over x squared plus 1 and let's do two non-repeating quadratic factors times x squared plus 3. So first I have two non-repeating quadratic factors that can't be factored. So how's that going to work? Well, you got to consider first the degree of your numerator is less than the denominator, which is good. Now consider your first non-factorable quadratic factor. The degree of your first numerator still needs to be 1 degree less than the degree of your denominator. So that should end up being ax plus b all over my x squared plus 1. And then I need to do, you guessed it, I'll end up doing a cx plus d all over x squared plus 3. So there's going to be for my two non-repeating unfactorable quadratic factors. Now multiply both sides by the common denominator. You should end up getting x squared plus 2x plus 3 would equal multiply the first term, you'll end up getting ax plus b times x squared plus 3, plus now you'll end up getting that cx plus d times that x squared plus 1. So let's go ahead, FOIL everything, and simplify this. This would turn into x squared plus 2x plus 3 is going to end up equaling ax to the third plus 3ax plus bx squared plus 3b plus cx to the third plus cx plus dx squared plus d. So I know that looks rather long, but that's how it works. Now on the right hand side, let's group like terms. So you'll have x squared plus 2x plus 3 is going to equal, let's group your x to the third terms together first. That would end up being ax to the third plus cx to the third. Next, worry about your x squared term, so that'd be plus bx squared plus dx squared. Next, worry about your x to the first term, so that would end up being plus 3ax plus cx, and then do your constant terms, which would be plus 3b plus d. Okay, so now let's factor out the common factors. You'll have x squared plus 2x plus 3. Now let's factor out the common x cubed. That would be a plus c times x to the third. Then factor out your common x squared. That'd be plus b plus d times x squared. Factor out your common x to the first. That would end up being plus 3a plus c times x to the first, and then factor out, of course, your constant, which really doesn't need factored. That'd be 3b plus d. And then the left side should equal the right. A plus c is the coefficient of your x to the third term, which is 0. So a plus c equals 0. Then you have b plus d is the coefficient of your x squared term, which is 1. So b plus d equals 1. 3a plus c is the coefficient of your x to the first term, which is going to be 2. So 3a plus c equals 2. And then 3b plus d should be your constant term, which is 3. So 3b plus d equals 3. You have 4 variables and 4 equations. But this isn't going to be as bad as you think. You want to know why? Because you can do a plus c and 3a plus c and solve for those 2 variables. So if I take a plus c equals 0 and 3a plus c equals 2, I can easily eliminate the c and solve for a. That would end up being negative 2a equals negative 2, which would mean a equals 1. Now it's easy. All I got to do is put in my a value in the top equation and solve for c, which means c would have to equal negative 1. So we actually already found a and c. We just need to do the same for b and d. So you can deal with b plus d is equal to 1, and then you'll have 3b plus d equals 3. So then you can subtract the second equation from the first. You'll end up then with negative 2b equals negative 2, which would have to then mean that b equals positive 1. So we found b. Now what about d? If I put it into the top equation, I'll get d equals 0. So I actually get nowhere for d. I'll have a d value of 0. But I at least now have my partial fraction decomp, which would end up being x plus 1 over x squared plus 1 minus x over x squared plus 3. And then there is my partial fraction decomposition for the original fraction. And if we did have repeated quadratic factors that couldn't factor, it's really not much different than dealing with repeating linear factors. The only difference is, like, I'm not going to do the full exercise, but I'll just show you what you'd be up against. So let's say I just decided to do x squared plus 2x plus 3 all over a simple x squared plus 1, that quantity squared. You know what? Why don't we do this one? I don't think it's going to be that bad. So you have a repeating quadratic factor that won't factor. Well, what you'll do is you'll still set up an ax plus b over x squared plus 1 raised to the first power plus a cx plus d over an x squared plus 1 raised to the second power. Now that ain't so bad, because you just multiply both sides by the same common denominator. You'll end up getting x squared plus 2x plus 3 is going to equal that ax plus b times x squared plus 1. And then in the second term, you'll just have plus cx plus d. So let's expand the right-hand side first. That'd be x squared plus 2x plus 3 would equal ax to the third plus ax to the first plus bx squared plus b plus cx plus d. And then, of course, bring your like terms together. You'll have x squared plus 2x plus 3 equals ax to the third, which is your only x to the third, plus your bx squared, which actually is your only x to the second. Then you have ax plus cx, which is actually pretty easy. We can just factor that into plus the quantity of a plus c times x. And then you just have plus b plus d. So a would be the coefficient of your x to the third term, which right away is 0. A equals 0. Not a whole lot we can do with that. B's the coefficient of your x to the second term, which is 1. So we're already getting terms. B is 1, and then you'll end up having a plus c equals your x to the first term. So a plus c equals 2. Well, if a is 0, that means that c would have to equal 2. And then b plus d is going to end up equaling your constant term. So b plus d would equal 3. Well, b is 1, so that means d plus 1 equals 3, which has to mean then that d equals 2. So now we found a, b, c, and d. We have the partial fraction decomp. So a is 0, nothing we can do with that, but b is 1. That'll be 1 over x squared plus 1. Plus my c was 2, so that'd be plus 2x plus my d of 2, plus 2x plus 2 all over my x squared plus 1 squared. That would end up being my partial fraction decomp of this fraction. Now I got just 2 more exercises, and I want to get into when the numerator is equal to or greater than the degree of the denominator. What do we do with that? All right, so let's say you have something like this. You have 2x to the third minus x squared plus x plus 5 all over x squared plus 3x plus 2. So we can very clearly see the degree of the numerator is actually greater than the degree of the denominator. If it's equal to or greater than the degree of the denominator, what you first need to do is do your polynomial long division. So we're actually going to do some polynomial long division first. So 2x to the third minus x squared plus x plus 5. All right, divide all that by my x squared plus 3x plus 2. So x squared goes into 2x to the third how many times? Just 2x times. And then you'll end up having, of course, 2x times x squared is 2x to the third. And then 2x times 3x, that's going to be plus 6x squared. And then you'll end up having 2x times 2, that's going to be plus 4x. So now let's go ahead and do some subtraction. 2x cubed minus 2x cubed is 0. Negative x squared minus 6x squared, so that's minus 7x squared. X minus 4x, that's minus 3x. And then you'll simply have your plus 5 that you'll bring down. Okay, so x squared goes into negative 7x squared how many times? Just minus 7 times. So then you'll have negative 7x squared minus 21x minus 14. Do some subtraction. The x squareds cancel. Negative 3 plus 21, that's 18x. 5 plus 14 is 19. So you have a remainder of 18x plus 19. So this would be equal to 2x minus 7 plus 18x plus 19. The 18x plus 19 is my remainder of the x squared plus 3x plus 2, which would actually factor into x plus 1 times x plus 2, right? All we have to worry about now taking the partial fraction decomp of is going to be the remainder. That's all we have to worry about. The other two terms are good. We only have to worry about taking the partial fraction decomp of the 18x plus 19. So I think we can go ahead. I'm going to erase this here. I think everybody's got a pretty good grasp on polynomial long division by now. So ignore the 2x minus 7. Let's go ahead and set up that 18x plus 19 all over that x plus 1 times x plus 2. Well, we have non-repeating linear factors, so that would just be equal to a over x plus 1 plus b over x plus 2. Multiply both sides by the common denominator, you get 18x plus 19 is going to be equal to a times x plus 2 plus b times x plus 1. So 18x plus 19 equals ax plus 2a plus bx plus b. So group your like terms. 18x plus 19 that would just equal a plus b times x plus my 2a plus b. So a plus b is my coefficient of the x of the first term, so a plus b is going to be equal to 18, and then 2a plus b equals my constant term, which is 19. So now let's go ahead and subtract the second equation from the first. We can eliminate b. You end up getting that negative a equals negative 1, which just simply means that a equals 1. So we found a, and we can easily solve for b by putting it in the first equation. So b plus 1 equals 18, so b equals 17. So your final form after the partial fraction decomposition is going to be 2x minus 7 plus my 1 over x plus 1 plus 17 over x plus 2. So a lot of people, what they'll do in this situation is they'll write out the partial fraction decomp, but they'll forget to add the two original terms from when you did the long division. So here is really the full form of the partial fraction decomp and the completely factored version. I'm going to do just one more like this, then we're done. Whoops, I thought I almost dropped my eraser for a second. All right, let's do the last one, eh? X to the third plus 2x squared minus x plus 1, all that divided by x squared plus 3x minus 4. So I got x to the third plus 2x squared minus x plus 1 over x squared plus 3x minus 4. Well, degree of the numerator is greater than the degree of the denominator, so first thing we actually need to deal with is doing polynomial long division. So let's take x to the third plus 2x squared minus x plus 1, divide all that by x squared plus 3x minus 4. X squared goes into x cubed x times. So x times x squared is x cubed plus 3x squared minus 4x. So subtract this here. X cubes are gone. You'll get negative x squared plus 3x. Now go ahead and bring down your plus 1. X squared goes into negative x squared minus 1 times. So this would turn into minus x squared minus 3x plus 4. Go ahead and subtract your equations. X squareds are gone. You end up getting 6x minus 3 as your remainder. So 6x minus 3 is your remainder. So this will turn into x minus 1 plus that 6x minus 3 all over this x squared plus 3x minus 4, which would factor into, that should be x plus 4 times x minus 1. Yep, so the only thing now we have to worry about taking the partial fraction decomp of is the remainder. That's 6x minus 3 over the factored form of the denominator. So let me erase this polynomial long division so we don't run out of room. So let's just deal with 6x minus 3 all over that x minus 1 times x plus 4. So what's nice is we have non-repeating linear factors. So this is just going to be the standard a over x minus 1. plus b over x plus 4. Alright, so multiply both sides by your common denominator, so you'll end up getting 6x minus 3 equals a times x plus 4 plus b times x minus 1. Go ahead, do your distribution on the right hand side, so 6x minus 3 equals ax plus 4a plus bx minus b. Group your like terms together. In fact, we'll even do the factoring step. So 6x minus 3 would equal a plus b times x plus that 4a minus b. Well, a plus b is my coefficient on the x to the first term, so a plus b would equal 6. 4a minus b is my constant term, so that means 4a minus b equals negative 3. So I can just add these two equations together and I can eliminate the b term temporarily. So what does that mean? That means that 5a would equal 3, so a would have to equal 3/5. So a is 3/5. We can easily find b by putting that into the first equation. So b plus 3/5 equals 6. Well, 6 in terms of 5 is going to be 30/5, so that means b would have to be 27/5. So now we know b, we know both a and b, we can do the full partial fraction decomp. But don't forget to take your original x minus 1 and add that to it. So the really full factored form with partial fraction decomp is going to be x minus 1 plus my 3/5 over x minus 1 plus my 27/5 over x plus 4. So that would be my fully factored form with partial fraction decomposition. So that's it for this lesson. I'm sorry it went on longer than I planned, but I wanted to be thorough because, as you see, there are different types of partial fraction decomp, and they're very important for calculus. Next lesson, we're going to introduce matrices. So I hope everybody has a great day. Take care.